very well. That will be joining us very soon. So, and the determinants I'm going to cover using quicker method. There is a quicker method you can use to find the determinant of 2 by 2 matrices. You understand now, so that you don't need to stress yourself. If it comes as MCQ, then you can quickly solve it without problems. So without problems. And if time permits us, I'm going to briefly, explain binomial theorem as well. I don't know if that is coming out as part of your scope. So yeah, that's what I'm going to cover today. But before I start, do we have any, a question perhaps based on what we've covered so far, or based on what is not clear to you on what you've done, so that I can take that into account and explain them together? Any question? Yeah, I think some of you are asking about the link. Could you guys just maybe share them the link? Okay, maybe I should just copy it here. So any question from the group before I start? Do you have any question perhaps on what is not clear to you, on what we've done, or on what we've done before, so that I can explain them to you? Hello? Okay, somebody just wrote there. Okay, thank you. You send the link. So I think maybe I should also send it as announcement, so that all of them can see. Maybe that's why we have, a lower, there are many people are not joining us. The link below. So in the absence of no question from the group, so I think it suffices for us to start. And then maybe I should just copy you the, thank you, Longani. Yeah, I want to copy you the attendance as well, for those who are joining, so that you can fill your attendance. Okay, here you go. Okay. So last week before we departed, I said one of the application of matrices is you can use it to solve a system of linear equation. And one of the ways you can solve a system of linear equation is through what we know as, echelon reduction. And if you don't forget, I told you that when you say a matrix is in an echelon form, then you are going to have something of this nature. You must first of all have 1 as your first element here. So then you have 1, so maybe dot, dot, dot. Then you must have 0 here, dot, 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 0, 0, dot, dot, dot. Then you can have 0, 0, 0, dot, 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 dot as well. I hope you understand now. So that's echelon form. And maybe when you have something of this nature, at the end of the day, you have 1, maybe say 2, 3, 0, 1, 4, 0, 0, 3. And you have something of this nature here. So if you have X, Y, Z here, so what this one is saying is that by echelon form, you can use it to find the value of 3Z. Because you want to write it as a system of equation you had before, that will give you 4x plus 2y plus Please, you guys mute yourself. Please, those that make the co-host, will you help me just mute them as soon as they do that? So, and this one will give me y plus 4z is equal to 5. So then you have 3z is equal to 6. So from here, I can find the value of Z. As soon as I know the value of Z, here to be 2, you know, Z here implies 2. Then you can use it to find the value of Y. Once you know the value of Y and Z, then you use it to find the value of X. I hope that helps. So yeah, please, just a minute, guys. Sorry, guys, I'm back. So that's one of the, advantage of row-reduced echelon form. So, and another way, another advantage is that you can use it to, you can use your Gauss Jordan elimination method. So Gauss Jordan elimination method. So that at the end of the day, what you reduce would be of this form, 1 0 0 0 1 0 0 0 1. You understand now? So, and at the end of the day, so you can say that your Z will be 7, your Y will be 3, and your S is 2. So we discussed about this last week. So, but today, how do you now find inverse of a matrix by row reduction? Before I start, what do I mean by inverse of a matrix? You know, inverse of a matrix A. So when we say inverse of a matrix A, which is denoted by this, you know, when you've done your binary operation, when you say inverse of a matrix, that is what are you going to multiply by a matrix to give you that matrix back? I hope you understand now. So what am I going to multiply by A? You understand now? Or A multiplied by A inverse that will give you I. So where your I is what? Your I is an identity element. So your I is an identity element. Okay, you're welcome, Zondi. So if that is cleared, if that is now cleared with you, so then if you now want to use this one, this method, the row reduction method to find the inverse of a matrix, maybe I should use the one in your tutorial question so that we can just look at that together. So you're asked to solve this. Let me just copy the question here straight away. Okay. I'm coming, just a minute.
Okay, bon. Ah, come on, child.
Can you see the question? Look at this question. We have to find the inverse if it exists. How do you know a matrix? You know, not all matrices has their inverse. I'm going to explain when I get to determinant of a matrix. So we call something singular matrix. You understand now? Singular matrix are matrices where the determinant is what? Is 0. So when you have a matrix whose determinant is 0, then you cannot find the inverse of such a matrix. I hope you understand now. So, okay, now let me use this first one as an example for you. We have our A to be what? We have our A to be 6522. A is equal to 6522. You know what you have to do first is to write it as an augmented form. In augmented form, since you want to find the inverse of this, then you are going to have something of this nature, AI. So your I is your identity element, your identity matrix under 2 by 2. Then you are going to have something of this nature, 6, 5, 2, 2. I hope you understand now. Then 1, 0, 0, 1. Trust you understand. So then you are now going to resolve it such a way that at the end of the day, you are going to have A inverse, or let me say, yeah, here you are going to have you are going to have I here, then you are going to have A inverse on the other hand. I hope you understand. You see what we've done? What we've done here is that for A here, you know, we have A here before. When you multiply A by A inverse, we are going to have I, which is identity element. Identity element is what are you going to multiply? I mean, A inverse is inverse of a matrix is what are you going to multiply by a matrix to give you identity element back? Just like, you know, if you have 2, multiplicative inverse of 2 is 1 over 2, which will give you 1. So likewise, in the context of matrix, inverse of a matrix is what are you going to multiply by a matrix that will give you identity element? I mean, a 2 by 2 identity matrix. I hope you understand now. So then the process of resolving this I here and having A inverse here is what you are going to have. Okay, now let's see what are you going to do. What are we going to do to ensure that we have I here? We reduce this to be of the form 1, 0, 0, 1. So then what you have at this side will now be your inverse. Okay, let us do it again. How do we do that? If I were you, I can just divide this by 2. You understand now? So then you can just say, maybe you have 6, 5, 1, 0. Then you can say R2 divided by 2. You know the reason why? If I say R2 divided by 2, then it means I want to reduce this guy to be 1. Since we are interested in making this 0 and this to be 1. You understand now? So then this will be 1, 1, 0, half. We do it for all of them. I hope you understand. Now recall, we want to make this to be what? To be 1 as well. How do you make it to be 1? What you have to do is to what? You can also divide. You divide by 6. Because it is not 0, we want to make it 2. So you have to divide this by 6. Maybe you have R1 divided by 6. Then this will give me 1. 6 divided by 6 will give me 1. This will be 5 divided by 6. This will be 1 divided by 6. And 0 divided by 6 will give me 0. I hope you understand now. Then you have what? 1, 1, 0, half. Then what you can still do here is, now we want to make this to be 0. But before you do it, why not try this and make this to be 0 first? You can quickly make this to be 0 by saying R2 minus R1. You understand now? Maybe 1, 5 over 6, 1 over 6, 0. Then 1 minus 1, this will give me 0. I hope you understand. 1 minus 5 over 6, 1 minus 5 over 6. So that will give me what? This is 6. So I think that is 1 over 6. 0 minus 1 over 6 will give you minus 1 over 6. Then half minus 0 will give you half. Then we are getting there. What do you have left here to make this guy to be 0? How do you make it to be 0? It is not difficult at all. Okay, how do you make it to be 0? And ensure that this is not affected. Anybody? How do we make it 0? Given and ensure that this guy is not affected. Okay. Anybody? You know, I can say this, maybe R1 minus 5R2. R1 minus 5R2. You know, the moment we can make this guy to be 0 if these and these are the same. Then if they are the same, you can just say 5 over 6 divided minus 5 over 6. Then you are going to have 0. Then how do you make this 5 over 6? Multiply it by 5. That's what I've done here. Then you now say 1 minus 5 times 0. This will give you 1. Then 5 over 6 minus, you know, 5R2 now will be 5 times 1 over 6. So 5 over 6 minus 5 over 6 will give you 0. I hope you understand now. Then this will also be what? 1 over 6 minus 5 over 6. 1 over 6 minus, that will be plus 5 over 6. That's 6 over 6, which is 1. This one will give you 1. This will be 0 minus 5/2. That will give me minus 5/2. You understand now? Okay, how do you make this to be 1? You can make this to be 1 by multiplying by 6. This will now be 6 multiplied by R2. 6 times 0. That will give me what? 0. This will give me 1. So this will give me minus 1. I hope you understand, because 6 times this will give me minus 1. Then this will give me 3. I hope you understand now. So then you can now conclude adequately that your A inverse will now be what? 1 minus 5/2 minus 1, 3. I hope you understand, guys. So that will now be your inverse. You can see we reduce it from this form, then we change it here. So we change it I here, I A inverse. So, and this will now be your A inverse, what you arrive here, what you arrive at here. Okay, now that's one of the methods. Maybe I should use another method for you. I think that is more cheaper. So that method is more cheaper. So what is the method? So you know the question gave, we have 6, 5, 2, 2. Okay, I think there's a question. So how do we find the value such that the system has an inverse? Yeah, Ayanda, could you repeat your question? I don't understand what you are asking. Could you be more explicit? Do you mean when you have it as a system of linear equation or what? Or do you have such a question? Ayanda? Can you unmute yourself and talk? Hello, Ayanda, are you with us? Or let me check, is that kind of question among your, I don't think,
okay.
I can't.
Sorry, I
can see that question. I think the question is on number 4, right?
It's on tutorial 5.
Tutorial 5. I think you are referring to this kind of question. Okay, let me see if I can copy it here. Okay. I'm coming. Yeah, it is not difficult to do. So find the value of K such that this guy has an inverse. Okay. Let me copy it here. So the question asks us to find the value of K such that, so A, which is 1, 2, K3, has an inverse. You understand now? So such that it has an inverse. Then you have to find what is the inverse of K. What is the inverse of K? Okay, that is not difficult to do as well. But before I solve that question, maybe I should, tell you the second method as well. Then we can use either of the methods to solve this kind of problem. Is that fine with you? You know, the second method I told you is by determinant method. Okay, thank you. So when we say determinant is the value that is obtained from a square matrix. For example, when I have my A to be 1, 2, 3, 4, you understand? Determinant of A, which is denoted by this, is what? 1, 2, 3, 4. What you have to do is to what? You multiply the element of matrix along the leading diagonal. That will be 1 times 4. You understand now? Then minus the element, the product of the elements along the second diagonal, 3 times 2. That will give me 3 times 2. Then you are going to have 4 minus 6, which is equal to minus 2. I hope you understand. Okay, now let's say we want to find this. If your A is 2, 3, 1, 8, Then what will be your determinant of A? You know, your determinant of A will be 2, 3, 1, 8, right? Okay, with what I've said, this will be 2 times 8, which is 16, minus 3 times 1, which is 3. Then we are going to have 13. I hope you understand now. So that is that for determinant of a matrix. How do you now use determinant of a matrix to find the inverse of a matrix? It is not difficult. Inverse of a matrix has this formula. It is the same thing as adjoint of A divided by determinant of A. Don't let me stress you with these terms, since I don't think they use this scope to teach you. But if you want to find the determinants using a quicker method, if you want to find the determinants using a quicker method, maybe I have my A to be 1, 2, or let me say A, B, C, D. Then what you are going to do, determinant of A will now be what? So the inverse of A will now be 1 divided by determinant of A. You understand now? Then you are going to have a matrix. Inside that matrix, then you are now going to interact the element along the leading diagonal. This will give me, you know, we have AD before, then it will turn to DA. I hope you understand now. Then you now multiply the element along the second diagonal by -1. This will now be minus B minus C. I hope you understand that. Minus B minus C. This is what I'm trying to say. Let's say I want to find the determinant of minus B minus C. Let's say I want to find the determinant of this matrix, but this quicker method is only applicable for 2 by 2 matrix. If you want to find the inverse of 3 by 3 matrix, you have to use adjoint, but I don't think they teach you adjoint, so it means you use your row reduction method. But I want to teach you this maybe when you come across it, I mean, in your MCQ, then you should be able to solve directly. So let's say my A is equal to, why not use it to find the one we found the other time? What is the matrix? We have 6, 5, 2, 2, 6, 5, 2, 2, 6, 5, 2, 2. Don't forget, if you want to use this shortcut method, then your A inverse will now be what? 1 divided by determinant of A. That is when you don't want to use the row reduced echelon form I've just, I've just explained. You understand? And so you interact this guy with this guy. You know it is 6, 2 before. You change it to 2, 6. And you multiply this element along the second diagonal by -1. And this will now be -5, -2. -5, -2. You understand now? Then your A inverse will now be what? Okay, let us find this determinant. How did I call the determinant? You know, the determinant of area will be what? What did I ask you to be doing? Multiply element along the leading diagonal, 6 times 2. That will give me 12 minus element along the second diagonal, 5 times 2, which is 10. 12 minus 10 will give me 2. It means determinant of A is 2. Then you have 2 minus 5 minus 2, 6. You understand now? So, you know, if you multiply it through by half, then this will now be 2 times half, which is 1, minus 5 times half, that will be -5/2. So then this will be -1, and this is 3. When you see, we arrive at the same result. Guys, can you see we arrive at the same result? 1 minus 5/2. Can you see? Can you see that one is much simpler? You don't need to stress yourself with this shortcut method. I hope you understand what I've just done. Anybody, if you understand, can I see you type on the group? Hello, do you understand the method?
No, sir, can you repeat that?
Okay. 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 No problem. No problem, Karina. I will do as you suggested. So somebody said the second method is not clear. Okay.
Oh, attending. I see class SI.
So somebody said the second method is not clear. Maybe I should explain again. So, okay. Okay, for the first method, maybe I should explain the two. No problem. No problem. Okay. Don't worry. I want you to understand. You know, the first method, which is the method you were taught in class, is using row reduction method. You know, by row reduction method is when you have a matrix A, for example, you understand now? When you have a matrix A, for example, then you are now going to write it in an augmented form, maybe as I. You have A here, I here, where your AI is an identity matrix. And don't forget, by the definition of identity matrix, when you say an identity matrix is a matrix whereby all the elements are 0, except those along the leading diagonal, which is 1. That's this 1, 1, 0, 0. So this identity element for 2 by 2 matrix. Identity element for 3 by 3 matrix are 1, 0, 0, 0, 1, 0, 0, 0, 1. If you check it very well, you will see all the elements are 0, except those along the leading diagonal this way, that are what? That are 1. I hope you understand. So if you now want to use your augmented matrix to find this, it means when you have a matrix, for example, now we have this matrix 6, 5, 2, 2. 6, 5, 2, 2. You know, these are matrix A. If we are now asked to find the inverse of A, you understand? Maybe instead of us, yeah, okay. If you want to find the inverse of A, then you are going to put it in an augmented form. That will now give me 6, 5, 2, 2. That is, you have your A, I. You understand now? Then you are going to have this, your A, right? Then you have your I is 1, 0, 0, 1. If it is 3 by 3 matrix, then you are going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. I hope you understand now. So that's what you are going to have. But since it is a 2 by 2 matrix, that's why we have 1, 0, 0, 1. Then what we are interested in is what? Is changing this matrix. You know, we have A, I here. Then your augmented matrix at the end of the day, you have to have something of this nature, I, A inverse. I hope you understand now. So such that you reduce this one, this matrix, to be of the form 1, 0, 0, 1. Then any other matrix you have at your right-hand side now will not be your inverse. I hope you understand that. So it will not be the inverse of that matrix. I hope you understand now. So that's that. Okay, now let us do that. You know, what we are interested now is to make this guy 1, 0, 0, 1. So we want to make it 1, 0, 0, 1. And I said, the first thing to do is that since we are interested in making this guy to be 0, 0, 1 before, why not you divide 2 by 2 so that you have 1, 1? Yeah. So you can reduce it, although if you don't reduce it, you are still going to arrive at the same result. You know what we can do there is to just say root 2 divided by 2. We want that to be applicable to root 2 as well, only. So that is, if I divide 2 by 2, yeah, what you do for an element, you have to do it for all of them. Then this one will give me 1, right? So then 2 divided by 2 again, 1. 0 divided by 2, 0. 1 divided by 2, half. I hope you understand now. So since what we are interested in is to what? Is to change this guy to be 1, 0, 0, 1. Okay, now it means this guy, this 6 should also be 1. Then how do you make it 1? What you can do is to what? What if I say, if I have, you know, this is 6, right? And I want to make it 1. How do you make 6 1? You divide by 6. I hope you understand that. Then you can now also say row 1 divided by 6. And if you have row 1 divided by 6, then you are going to have 6 divided by 6, 1. You know, our mission is accomplished. 5 divided by 6. 5 divided by 6 will give me 5 over 6. 1 divided by 6, that will also give me 1 over 6. 0 divided by 6, that will give me 0. I hope you understand. Okay, now, then you can write this as it is, 1, 1, 0, half. Okay, you know, out of the 4 things we want to do, we've done 1. You know, we want to make this one to be 1. We've done that. We want to make this one to be 1. It is 1 already. But we want to make this guy to be 0. We want to make this guy to be 0 as well. I hope you understand that. So we want to make this guy to be 0 as well. So then how do we do that? One way we can do is, maybe if you want to make this guy to be 0 is, we can quickly, you can use any, rule you want. So if you don't want to use the one I used the other time, one way I can do is, since I want to make this to be 0, one of the way to make this to be 0 is if I have the same number here. I hope you understand now. So if I have the same number here, if I have the same number here, then it will be easier for me to subtract the two numbers from each other and this guy to be 0. Then another way you can do is to what? Make this guy 0 first. And this one is easier. I can make this to be 0 by subtracting this from this. That's why I use another rule that, okay, now, why not say row 2 minus row 1? If you apply row 2 minus row 1 for the second row, since we are applying it for the second row, this one will remain as it is. 1, 5/6, 1/6, 0. But for this one, we want to apply row 2 minus row 1 because we want to make this guy to be 0. This will be 1 minus 1, 0. Then 1 minus 5/6, that will give me 1/6. What you do for one element, you have to do it for all the elements. 0 minus 1/6, that will give me minus 1/6. Half minus 0, that will give me what? Half. I hope you understand now. Another mission accomplished. You understand now. So another mission accomplished. Okay, what are we going to do? We want to make this guy to be 1. We want to make this guy to be what? 0. How do you make this guy to be 0? So why not multiply this by 5? If you multiply this by 5, it's going to be 5/6 and subtract the 2 from each other. I hope you understand. And that's why I said, okay, now, let's say R1 minus 5R2. You know the reason why? This is 5/6 already. Make this guy 5/6 too, so that as soon as they are having the same number, you can just subtract straight away. Then you now have 5R1, which is 1, yeah, minus 5R2. 5 times 0, which is 0. 1 minus 0 will give me 1. Then this will be 5/6 minus 5 times 1/6, which is also 5/6. 5/6 minus 5/6 will give me 0. R1 again, 1/6. If you don't know it often, you can write it down. Minus will give me plus 5/6. 1/6 plus 5/6 will give me 1. I hope you understand. Then also 0 minus 5/2. 0 minus 5/2 will give me what? Minus 5/2. That is 1. Okay, now we want to make this guy to be what? To be 1 as well. And we are having 1/6 here. What can you do to make this 1? If I multiply this guy by 6, it's going to be 1. That's why I said, okay, now let's say 6R2. Since that will not be applicable to this element alone, you have to do it for all of them. Then if you have 6R2, then I'm going to have 6 times 0, 0, 6 times 1/6, that is 1. So then 6 times minus 1/6, that will give me what? Minus 1. And this one will give me 3. You understand now? You can see at your left-hand side now, we have something of this nature, A inverse. So what you now have at this side is your A inverse. Then you can conclude adequately that your A inverse is equal to 1 minus 5/2 minus 1, 3. That's the first method. The second method is, what if you don't want to stress yourself? You understand now? So the second method is by determinant method. It is very fast. When you have it in your MCQ, you don't need to stress yourself. Just use the first method and do it directly. And how about the method? But before I go, do you understand that of row reduction? Especially the guy who asked me to repeat the question. Thambile. Okay. So for determinant method, if you want to use determinant method, first of all, you have to know the meaning of determinant. What is determinant? When I say determinant of a matrix, okay, thank you, Thambile, I'm happy you are clear with it. So when I say determinant of a matrix, so determinant of a matrix A is denoted by that A. You understand? Maybe I have my A to be A, B, C, D, and you want to find determinant of A, or in some textbook, they write it like this. You understand now? Then your determinant will now be what? A, B, C, D. Then what you are going to do is to what? You multiply elements along the leading diagonal. That will give me what? A times D, which is AD, minus element along the second diagonal, B times C, which is PC. You understand now? Okay, now, with that explanation, who can tell me the determinant of this matrix? When I have my matrix to be, if I have matrix A to be 1, 2, 3, 4. Who can tell me the determinant of A with what I've just explained above? Then before I apply it to inverse. Anybody? Anybody? 0. Is it? Check it very well. Ayanda. Is it 0? Don't forget, if you want to find the determinant, and by the way, Ayanda, if a determinant of a matrix is 0, then you cannot find the inverse of that matrix, because that is called a singular matrix. Let us do it together. You know, the determinant will now be multiply the element along the leading diagonal. That is 4 times 1, 4, minus element along the second diagonal, 3 times 2, which is 6. Then you are going to have minus 2. That's best. Yeah, minus 2. I hope that is clear. Yeah. Okay, Ayanda, thank you. Fambide, thank you. So it is minus 2. Okay, now, what if you now want to use the idea of a determinant method to find your inverse? That is also possible. How do you do that? Let us use the same example we had up. But before I use the example, if you want to find the inverse of a matrix using this method, it will now be 1 over determinant of that matrix. Maybe if my A is again A, B, C, D. Then if you find the 1 over determinant of A, then what you are going to have inside this matrix will now be what? You interact the element along the leading diagonal here. This will now give me A instead of AB before. Then you now multiply element along the second diagonal by minus 1. Then this will now be minus B minus C. I hope you understand. So again, if my A is 1, 2, 3, 4, and you want to use this method to find the inverse, then the inverse will now be 1 over determinant of A. What is determinant? You know, the product of element along the leading diagonal and along the second diagonal. That's 4 minus 6. Then you now interact this matrix. So, you know, you have 1 here, you interact 1 with 4, then you are going to have 4 here, 4, 1. Then you multiply this guy by minus, this will be minus 3, minus 2. So then your inverse will now be what? 1 divided by minus 2, 4, minus 2, minus 3, 1. You know, this is very simpler, especially when you have it, I mean, in your MCQ, you don't need to stretch yourself. Okay, let us apply the same method with the first question we solved. That is where we find the inverse of what? What is the question? 6, 5, 2, 2. Okay, I want us to do it together. 6, 5, 2, 2. Let's say we want to apply the inverse, the determinant method. Then A inverse will now be what? Okay, everybody. Yeah, I want somebody to unmute him or herself so that we say it together. That will give me 1 over, Don't be shy, be a friend. So that will be what? 1 over, you know, determinant of A will be what? 6 times 2, 12 minus 5 times 2, 10, right? Then after finding 1 over determinant, you now have a matrix, another matrix. In that matrix, you are going to interact the element along the leading diagonal. Okay, somebody has just written, thank you, half, okay. So then this will now be 2, 6. Then you multiply minus 1 by the element along the second diagonal. Minus 1 times 5, that will be minus 5 minus 2. Then your A inverse will now be what? 1 divided by 2, 2 minus 5 minus 2, 6, which is going to give me, if you multiply half by half, you know, 2 times half will give me 1, minus half times half will give me minus 5 over 2, minus 2 times half will give me minus 1, 6 over 2 is equal to 3. Can you see it is the same thing as what we had the other time? 1 minus 5 over 2 minus 1, 3, which is the same thing as this. When you see the beauty we have in mathematics. So if you have it in the exam, you don't need to stress yourself. Guys, I hope you understand the method now. Hello, do you understand the method? Okay, if you understand the method, can you quickly use that to solve this. I think one of the questions before I move to the question the guy told me. So when you have 4263, 4263, who can quickly tell me the inverse of this matrix? If it exists, 4263. This kind of inverse cannot exist. Do you know why it can't exist? So because the determinant of this matrix will give you 0. And if the determinant of a matrix is 0, then we say that matrix is a singular matrix, and you cannot find the inverse of a singular matrix. I hope you understand now. So, if you want to use the quicker method, that will be 1 over 12 minus 12. You understand now? And 1 divided by 0 will give you undefined, indeterminate. This is 3, 4, minus 6, minus 2. And because this one is 1 over 0, you can't find the inverse. Then the inverse does not exist. Why? Because A is a singular matrix. A is a singular matrix. Okay, what about this? What if you have 4, 2, 3, 5? Anybody? I want you to quickly check that. 4, 2, 3, 5. 4, 2, 3, 5. Who can quickly tell me? Guys, anybody? 4, 2, 3, 5. How do you do that? Okay. Question 2B, using the first method. Yeah, we can do that. I'm coming. Yeah, 1 over 14 is for the determinant. Okay. So this will be what? That's 1 over 20 minus 6, right? Then you interact the one along the leading diagonal. Then that will be 5, 4. You understand? And this will be minus 2, minus 3. So minus 2, minus 3. So then you are going to have 1 over 14, 5, minus 2, minus 3. You understand now? So that is that. But somebody asked, maybe I should use that method to solve question 2B in the tutorial. So that is, we want to use row reduction method. That is not difficult to do. So if the matrix is defined, yeah. Look at this question. Let me just copy it here. Can you see it? This is the question. Yeah. Okay. Before I do it first, please let me quickly find the determinant if it is not 0 so that we don't waste our time. This is plus, minus, plus, minus. Then you have 1, the minor of this matrix. That is, yeah, I think you should be able to find it. Okay, now, it is not difficult to do. Then you have your B. You first of all write your augmented matrix BI. I know your augmented matrix will now be what? 2 minus 3 minus 4, 0, 0, minus 1, 1, minus 2, 1. You understand now? Okay, or before I start, then you have 1, 0, 0, 0, 1, 0, 0, 0, 1. I hope you understand now. 0, 0, 1. If I were you, what I'm going to do first is to swap it. Swapping is allowed in matrix. This one is more like if I reverse row 2, row 3 here, if I put it here, maybe I have 1 minus 2 minus 1, so that I won't have much problem doing it. You understand now? Then I can bring this guy down, 0, 0, minus 1. So that I know that thing I'm going to do is to just multiply this by -1 to have 1. You understand now? And lastly, this one, maybe 2 minus 3 minus 4, 1, 0, 0. That is allowed. You can change any of the row as well as the, any of the rows. Okay, now, how do you reduce this? First thing you can do is to, maybe I can say this one first. Don't worry, maybe you have 1 minus 2 minus 1, 0, 0, 1. So what if What if I want to make this, we have to make this guy to be 0 as well. To make this 0, I can say R2 minus 2R1. That is multiplied 2 by row 1. If I multiply 2 by row 1, this one will give me 2. 2 minus 2 will give me 0. You understand now? Okay, let's say it is 3 here. Then you are going to say R2 minus 3R1 because we are interested in making this 3, making this the same number as you have here. So then if you do that, then you have R2 minus R1, 2 minus 2, that is 0. Minus 3 minus 2, that will be minus 3 plus 4, which is 1. Minus 3 plus 4 will give me 1. Then you still have minus 4 minus 2, because 2 times 1 will give me 2. Minus 4 minus 2 will give me minus 6. I hope you understand now. Then 1 minus 0, that is 1. 0 minus 0, that is 0. 0 minus 2. You understand? And that will give me minus 2. I apply the same law to each of the elements. You are getting there? Okay, now this is 0. I can make this one to be 1 straight away too. I can just say minus R3. That is multiply row 3 by minus 1. Then this will give me 0, 0, 1, 0, minus 1, 0. Do you understand now? So it means I've been able to find the one along the leading diagonal, just this, just to make this and this to be 0. You understand that? So then, how do we now make this to be 0? It's not difficult to do. I can quickly make this guy to be 0 by saying, this is 2 here before, minus 2 here before. What if I now say row 1 plus 2 row 2? This is minus 2 here before. And don't forget, I told you, if you want to make this guy to be 0, you have to note that, what you want to compare it with must be of the same number. You understand now? So if I make this to be 2 as well, then minus 2 plus 2 will give me 0. That's what I'm trying to say. So let's say, and I multiply this by 2, then they are of the same number, minus 2 plus 2 will now give me 0. Okay, now let us apply the rule. 1 plus 2 times 0. 2 times 0 is 0. 1 plus 0 will give me 1. Minus 2 plus 2 times 1. Minus 2 plus 1 will give me 0. Then 1 plus 2 times minus 6. That is 12, right? That is 1 minus 12. That will give me minus 11. I hope you understand now. Minus 11. Then R1, that is 0 plus 2. That will also give me 2. I hope you understand now. 0 plus 2 will also give me 2. I hope you understand I obtained 2. This is 0 plus 0. Then 1 minus 4. 1 minus 4 will give me minus 3. You are done with that. Okay, now this one, we're supposed to have 0 here before. You are supposed to have 1 here, and this one should be 0. How do you make this guy to be 0 as well? How do you make it to be 0? What if you say R2, that is row 2 here. If I say plus 6R3, if you multiply R3 by 6 now, it will now be minus 6 plus 6. That will also give you 0. I hope you understand. And then this will be 0 plus 6 times 0. That is 0. 1 plus 6 times 0. That is also 0. Minus 6 plus minus 6. That will be, no. Hello guys, sorry. Sorry, can you hear me now?
Yes,
Hello,
sir.
can you hear me now?
Yes.
Yeah, I'm sorry, for some strange reason I was sent out, I think by the network. Yeah, so I think I stop here. Then R2, this will now be, what are we doing? Okay, 0, where did I stop? Oh no, then 0, yeah, we've done with that. Now, what do you think is left? We've been able to accomplish this 1, 1, 1 along the leading diagonal. Then it's left to make this guy to be 0. Who can tell me the rule we are going to use to make this also to be 0 based on what I've been explaining? I want someone to say it among you. Anybody, please? Anybody? Anybody, my friend, please, I want you guys to talk. So while I'm waiting for you guys to talk, if you've not filled the attendance, please, could you just fill it? Anybody, please? I want to, what is left for us is to make -11 to be 0. How do we make it to be 0? Which rule are we going to use to ensure it is 0?
We are going to multiply
Yeah,
root 3
someone
by
want to talk?
positive 11.
Yeah, thank you, my friend. We can just say, this is -11. What we can do to make this guy to be 0 is to make this guy to be also be 11. Once it is 11, then you can just say -11 plus 11 times this. So in that sense, you are going to have R1 plus 11 R3. Oh, I hope you understand now. So R1 plus 11 R3. So if you now apply the rule, then I'm going to have 1 plus 11 times 0, that is 1. 0, then -11 plus 11, that will also be 0. 2 plus 0, that will also be 0. No. 2 plus 0, that's going to be 2. This is going to be 2. Then 0 minus 11, that is -11. Then -3, this will give me 0. -3 minus 0, that will give me -3. Then you can write the rest 0, 1, 0, 0, 0, 1. You can see we've been able to resolve this to be I, and then what you have at the other side will now be your inverse. 0 minus 1, 0 will now be your inverse. Then you can now conclude adequately that, so your A inverse is equal to what? 2 minus 11 minus 3, 1 minus 6 minus 2, 0 minus 1, 0. I hope you understand. Even if your matrix is 4 by 4, so what you have to do is to what? Write it as an augmented matrix first, and you have your identity matrix here. That's 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And try to, rewrite this as this, and what you have on the other side will now be your inverse. I hope you understand now. Do you get what I mean? Any question? Any question? Okay, before we move to another one, because I want to quickly, somebody asked about augmented matrix as well. So look at this guy. I think we've solved something of that nature last week, but let me snipe it too. Or maybe before I snipe, let's check the question my friend asked the other time. Snipe. Okay, we have to be very careful. Maybe I should do 2 of them together. Let me do 2 of them together. What about that? You're welcome, students, although I don't know your real name. Okay, look at this question. Look at this question. Can you see my screen? Okay, look at this question. The question says, consider the system of linear equations 6x plus 5y is equal to 13, 2x plus 2y is equal to 5. I don't think we need to stress ourselves. Do you know why I said that? We have 6x plus 5y is equal to 13. You understand now? Then we have 2x plus 2y is equal to 5. So we have 2x plus 2y equals 5. So then the question has, write the matrix form of the system of equation and then solve the system using inverse found in what? In Q1. You don't need to stress yourself. First of all, write it as a system. You know, this guy as a system will be what? Anybody? That will give me 6, 5, 2, 2, x, y, 13, 5. You understand now? So then we are now to write it as what? We were asked to use the inverse find in the first question before, the one we've done the other time. Recall, this is a matrix. If you multiply a matrix by its inverse, what did I said we are going to have? Look up, my guys. You know, I told you when you have your A inverse, A multiplied by A inverse will give you an identity matrix. You understand now? You know, this is a matrix A now. You know, as an augmented matrix, you have your A S is equal to B now. It means I want to find my S now. Why not multiply through by A inverse? Then I'm going to have A inverse multiplied by A multiplied by S is equal to A inverse multiplied by B. I hope you understand now. So such that if that is accomplished, A inverse multiplied by A will give me I, that is identity element. Identity element multiplied by S, which is A inverse times B. Then identity element times identity element multiplied by a matrix will give you that matrix. Then your matrix will now be what? The inverse of that matrix multiplied by B. That's what we are going to do. Okay, now let us multiply. Just multiply through by 6, 5, 2, 2 inverse. Anybody? What is the inverse of this matrix? I think we obtain it up. What is the inverse? Anybody? 1 minus 5 over 2 minus 1, 3. 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 You understand now? Then multiply by, what is our matrix A? What do we have on the left-hand side? So then we are going to have 6, 5, 2, 2, x, y. You see what I mean? Then this will be 13, 5. I hope you understand. So then if that is cleared, you will see that this multiplied by this, you know, this is inverse of this. What is the, who can tell me the product, like I've explained up, what is the product of a matrix and its inverse? What is the product of a matrix and its inverse? That will give us what? I've said it the other time. Anybody? Oh, what I have done for the left-hand side, I must also do it for the right-hand side. Sorry. So let me just clean this side. So this will be 6, 5, 2, 2. And what do we have up? What do we have by that side? That's 13, 5. 13, 5. Okay, anybody? What's the product of an inverse, a matrix and its inverse? I explained the other time. Okay, I can see. Yeah, identity Yeah, I think I'm having connection issue. I'm sorry for the interruption. So this is where we were before this guy interrupted us. You know, 13 times 6 will give me 8. That is 78. You understand now? Then you have 78 plus what? Plus 25. Then 2 times 13. You know, we are multiplying multiplication matrix. 2 times 13, that will give me 26 plus 10. I hope you understand now. Then you are going to have 103. And this is going to give me what? 36. Then you can conclude adequately that your S is equal to 103 and your Y is equal to 36. Can we try that, whether we are going to obtain it? S is 103, Y is 36. S is 103, Y is 36. We've not made a mistake. So if you don't make a mistake, I think you should be able to have it. Oh, I made a mistake here and you guys didn't correct me. You know, I was multiplying through by inverse. It was strange to me because I'm thinking you should not have this big number. You know, we are multiplying through by inverse. We're supposed to multiply this guy by the inverse, not the matrix its own. You know, this is what we're multiplying them by. We are multiplying by 1 minus 5 over 2 minus 1, 3. And this guy will be what? 1 times 13, that is 13, minus 25 over 2. You know, I'm multiplying 1 times 13 plus minus 25 over 2. Then minus 13 plus 15. You understand now? And this will now give me, so that is 1 over 2, I think. Am I correct? Yeah, that is 1 over 2, 2. Hi guys. Yeah, please, I'm very sorry for any inconveniences today. I don't know what's wrong with my connection. I hope it won't, do that again till I finishes the class today. Yeah. Oh. Yeah, just 12 of them. Maybe if you have like a WhatsApp group, you can inform them I'm back. It is my connection and it is very strange. So why it is doing like that today? Guys, what do you think? Could you guys help me, notify them that I'm back online? Hello, do you? Hello, guys, what do you think? Okay, maybe I should continue with this, with what I'm solving the other time. So let me just share the screen again for you to see. So the question says, find the value of k such that, A as an inverse. Okay, thank you, Ayanda, as you notify them. And you have your A to be what? 1, 2, K3. A is equal to 1, 2, K3. A is equal to 1, 2, K3. So then we are asked to find the value of K such that it has an inverse. You know, with the explanation I gave for the first time, I said, and if an inverse exists, then you know that definitely you can find the determinant. You understand now? The determinant is not going to be 0. I hope you understand now. So the determinant is not going to be 0. So then now if you want to find the value of k, I'm coming, we have 1, 2, K3. Excuse me. I'm coming. coming. Just a minute.
Text is that if it is not right, why do you think so? If it's wrong, why do you think so?
What did you say? Okay. Let me continue. I'm thinking of another method I can use for you. So one of the ways that, you know, when you have 1, 2, K3 here, such that the inverse exists, then you have something of this nature as usual. This is 1, 2, K3. You understand now? Then you have 1, 0, 0, 1. So one of the way you can do that is that if you don't want to stress yourself, you can reduce this as an echelon form. You understand now? You reduce this as an echelon form, or you reduce this. I mean, if this is reduced as an echelon form, and you know that before this, this number K, then you must not have 0, 0 here. You understand now? So then what I think you can do here is to, maybe let's see if we can reduce this further. So we have 1, 2 here already. Then I can divide row 2 by 3. If I divide row 2 by 3, then I'm going to have K divided by 3, 1, 1, 0, 0, 1 over 3. 1 over 3. So if that is clear, then it remains this guy to be 0. Then to make it to be 0, it is also simple. You can use your rule. What will be your rule? So I'm going to have that, maybe for example, if I say row 2 minus 2 row 2. Sorry, row 1 minus 2 row 2. So this is going to give me, no, we don't have 0 here first. That is wrong. I can't do it that way. I can't do it that way. I'm coming, please. I'm coming. I'm coming. I'm coming. Yeah. Now we were told that the inverse of that matrix exists. Let me check using this method, because this one might give you a problem. Although we can just say this. Okay, let's see. Let's see. I want to make this guy to be 0. Okay. So we have 1, 2, K3. You know, let's say I want to use the second method. You know, this will be 1 divided by 3 minus 2K. Then you have your inverse here. This is 3, 1 minus 2K. 3, 1 minus 2K. Please let me check the full question again. I think, I don't know if something is missing. find the value. Guys, are you with me? Can you check the question on your side to find the value of k such that if you have A1, 2, K3, I mean, if it has an inverse, I'm coming. I'm coming. So if your k is not equal to 0, okay, yeah. Okay, yeah, like I've said the other time, you know, by the definition of a singular matrix, if a matrix is singular, that is its determinant that A is not equal to 0. So since this matrix, also, I'm sorry, so since this matrix also has an inverse, it means your determinant of A is not equal to 0. You understand now? So it means the determinant of A is not equal to 0. So then if the determinant of A is not equal to 0, what is wrong? Samsung Note. So I will move to binomial theorem after this. Just let me do this sharp. Because before I'm thinking of a faster method I can use. So you know that singular matrix, since it has, you can just say since. So since inverse exists, that implies the determinant of A is not equal to 0. One of the ways you can use. And don't forget your determinant of A is 1, 2, K3. So if you say this is not equal to 0, then you have 3 minus 2K is not equal to 0. I hope you understand now. So if 3 minus 2K is not equal to 0, then you can say 3 is not equal to 2K. Then you can conclude adequately that your K is not equal to what? So your K is not equal to 3 over 2. You understand? And if K is not equal to 3 over 2, so your K can be, perhaps a real number. So, but I don't know. Do you have solution for this question? I mean, what did they obtain from the back? Anybody? What is the answer? What is the answer? What is the answer? Okay, while you are still thinking, why not move to, let me move to binomial theorem, so that if I have a contrary result to that, I can give it to you. I can give it to you, although I'm still checking. I'm still checking. So binomial theorem, you know, I made mention of that in the last, I think in the first class. And I told you for a binomial theorem, it is used to expand, I mean, a power, maybe when you have a cumbersome power. For example, when you have something of this nature, maybe you have a plus b raised to the power 20, a plus b raised to the power 20. You know, that might be hard for you to be saying a plus b times a plus b times a plus b. That is not true, that is wrong. So, but one way you can do this is to use you can do that in two ways to expand something of this nature. Number one, you can use your Pascal triangle. You can use your Pascal triangle. And I think I briefly explained what Pascal triangle means. Then for Pascal triangle, you have to know the coefficient of the power you want to expand. So you start from 1 here, then you can have 0, 1, 1. Do you know how to obtain this? You imagine there is a 0 here, then there is another 0 here. 0 plus 1 will give me 1. 1 plus 0 will also give me another 1. To obtain another one, you put 0, 0 here. This will be 0 plus 1, 1, 1 plus 1, 2, 1 plus 0, 1. To obtain another one, still put 0 here. This will be 0 plus 1, 1, 1 plus 2, 3, 2 plus 1, 3, 1 plus 0, 1. To obtain another one, put 0 here, 0 plus 1, 1, 4, 6, 4, 1. Again, this will be what? 1, 5, 10, 10, 5, 1. Again, this will also give me what? 1, 6, 15, 20, 15, 6, 1. So if you check it very well, you can see it looks like a triangle. It looks like a triangle, and that's why we call it a Pascal triangle. So, and this coefficient of 0, this coefficient of 1, this coefficient of 2, coefficient of 3, coefficient of 4, coefficient of 5, coefficient of 6. For example, now if I want you to expand s plus 2a everything raised by 3, you know, I made mention of that in the last class. You don't need to stretch yourself. Write the coefficient of 3 first. You say the coefficient of 3, like I've obtained here. What is the coefficient of 3? I think that is 1, 3, 3, 1. Then you now take that number one by one. You write the first coefficient. This will give me 1 times. I hope you understand now. Then you now have your x. Then your s will now start from the power. That is 3. Then the second term will start from 0. Even if you have 10 here, then the first time here will start from 10. The second time will start from what? 0. Then you have s cube 2a raised to power 0 plus. Then you take the second coefficient. What is the coefficient? Second coefficient, that is 3. 3 times. Then this one will be reducing. This one will be increasing. That's x squared, 2a raised to power 1. Then plus, what is the next coefficient? That is 3. This one will be reducing. The power will now reduce to 2. This one will be increasing. It will increase to 2 as well. I hope you understand. Then plus 1 times, this one will be increasing, x raised to power 3. This one will be reducing. That will give me, no, I think I made a mistake. This will be 1. This one will be reducing. This will be increasing. This will now reduce to 0. And this will now increase to 3. So if you simplify it further, then I'm going to have, so you know this is 1, s raised to power 3, n number raised to power 0 is 1, then plus 3s squared times 2a, then plus 3x, this will give me 4a squared, then plus 8a raised to power 3. And this will now give me s cubed plus is a s squared plus 12a a squared s plus 8a everything raised by 3. So that's Pascal triangle. Also, you can use like a combination for it as well. So if you want to use combination, it is not difficult to do. Then you now have, n combination. So you know this your n, that will be 3. Then you have 3 combination. So this will now start from 0. 3 combination 0. Then your S will start from 3. Then this guy will start from where? So what is it will start from 0 to 8. The second time will start from 0. What is 3 combination 1, everybody? What is 3 combination 1? That is 3 factorial divided by 3 factorial 0 factorial. So I think that is 1. Yeah, I'm correct. So then you now have 3 combination 1. That's another method. S raised power, this one will be reducing. 2a, this one will be increasing. Plus 3 combination 2, S raised power 1, 2a raised power 2, then plus 3 combination 3, S raised power 3, S raised power 0, 2a raised power 3. So if you check it very well, you will see that this one will give me 1. You have S cubed plus 3s squared multiplied by 2a. So 3 factorial, 3 combination 2 is also 3. Then you have 3s, 4a squared, then plus 8a cubed. That will now give me s cubed plus 6a squared plus 12a squared s plus 8a cubed. Can you see it is the same thing? That's how you can use a Pascal triangle. Any question? Do you understand what I've just said before I take an example from the book, from your tutorial question? Any question, guys? Hello? Any question?
No, sir.
Okay. So, yeah, look at this question. Let me just put it here. I want to copy it here. Can you see this question? Does anybody has an idea? You know, the first question you have in this expansion, find the coefficient of s raised by 6. Find the coefficient of s raised by 6. Anybody? Anybody who has an idea? Guys? So that is s raised by 6. S raised by 6. How do you find it? You know, this is 14 instead of you to be having, you know, instead of you to be writing something raised by, I mean, instead of you to be writing the coefficient of 14, there's a shortcut, you can use it. There's a shortcut you can use, that is a formula. I think it was written in your book. Does anybody know? Does anybody know? Well, let me give you a formula. If you want to find the kth term, you understand now. If you want to find kth term of an expansion, so you use this formula. Your kth term will be what? N combination k minus 1, s raised power n minus k minus 1. You understand now? So s raised by n minus k minus 1, then y raised by k minus 1. You understand now? So y k minus 1. So in essence, if I want to look at the second example here, look at the second example here. So where you asked to find, you know, you have 2s minus y over 2, everything raised by 5. Then we asked to find fifth term. Fifth term. Before I continue, this is your n. Your n is equal to 5. I hope you understand now. So your n is equal to 5. And your k, that is the number of term, which is fifth term as well. You understand now? It means your fifth term will now be equal to, okay, 5 combination. You know, now we have our k to be 5. Even if you ask to find 6th term or 7th term, what you are going to do is to what? Substitute the value here. That will be 5 minus 1. What is your s? This is your s. The first term is your s here. That is 2s raised to power what? N minus n, that is 5 minus 4. You know our k is 5. Then your y is all of these. Minus y over 2. K minus 1 is also what? Is also 4. So k minus 1 is also 4. I hope you understand now. And this guy will now give me what? 5 combination 4. Then you have 2s raised to power 1. And then you have what? Minus y divided by 2 raised to power what? Raised to power 4. What is 5 combination 4? That is 5 factorial divided by 5 minus 4 factorial, 4 factorial. That is 1 factorial, 4 factorial. That is 5 times 4 factorial divided by 4 factorial. So that will give me 5 times. So this is what? 2x, then y divided by 16. You know, 2 square will give me 16. Then I'm going to have 5 over 16, 2x squared. So no, 2x raised by y raised by 4. That will give you your what? That will give you your fifth term. What do you observe? What do you observe? You will see that if my fifth term is what? Give rise to, how do I call it? Look up. You know, if let's say we want to do this guy now, you know, my fifth term give rise to y raised to power what? Y raised to power 4. It means if I want to know y raised to power 6 or s raised to power 6, then what am I going to find? You have to find the 7th term using this formula. You understand now? So again, if you want to find the binomial coefficient of 7th term, so your 7th term again, if you want to use this formula, you know, your 7th term will also be what? N, that is 10 combination 6. Then your s raised power, that is 10 minus what? 10 minus 6, that is 4. Then y is equal to what? Y raised to power 6. Then your coefficient will now be what? 10 combination 6 itself. And what is 10 combination 6? You know, if they ask you to find the term directly, it will be 10 combination 6, s raised to power 4, y raised to power 6. But they ask you to find the coefficient of the 7th term, that is 10 combination 6 alone. That's going to give you 10 factorial, divided by 10 minus 6 factorial, 4 factorial, 6 factorial. So 4 factorial, 6 factorial. And now that's going to give me 10 factorial divided by, this will give me, anybody with calculator so that we don't stress ourselves, 10 factorial divided by 4 factorial, 6 factorial. You can say 10 times 9 times 8 times 7, you know, multiply by 6 factorial, that will give you 4 factorial. So, and 4 factorial is what? 4 times 3 times 2 times 1. So then you can say 4 here 1, 4 here 2, 2 cancel 2, 3 here 1, 3 here 3. Then you have 30. I think that should be 210. Right? Yeah, 210. Thank you, Luvo. So that should be 210. So, okay, we can use that idea, the same idea now to find the coefficient. of s raised power 6. How do you find the coefficient? The coefficient anybody using that formula? Just think, what gave, I mean, what gave, you know, when we find the fifth term, we notice that the expansion is what? We notice that the expansion was something raised to power 4. Then it means when you want to find that, what are you going to use? What are you going to use? Yeah, I think maybe I should write you the formula as well. I'm coming, let me get you the formula. Okay. Although if you want to, but using using binomial, using Pascal Triangle might give you a problem. Sorry. I'm coming. So, you know, here we have 2x minus 1 over x, everything raised to power 14. Everything raised to power 14. The only time we can have s raised to power 6 is what? When the other guy is what? So when the other guy is okay. Okay, yeah. You have, let me write it down. 2x minus 1 over s, everything raised to power 14. Okay, let's use this formula as well. Well, what are we going to put here to ensure that this gives us s raised to power 6? Just look here. You know, we have 14. Look at the formula I wrote here. You know, we have 14 here. What are you going to do such that this guy will be equal to 6? Our n is 14 here. It means you have to ensure that your k is 9. You understand? So when k is 9, then I'm going to have 9 minus 1, which is 8, and 14 minus 8 will give me 6. You understand now? Then you now assume that your k will be 9. So, and by that formula, how did I write it before? That is n combination k minus 1, n combination k minus 1. You see we have the term in terms of 6 now. Sn minus k minus 1, yk minus 1. I think I'm correct. S minus k minus 1, s minus k minus 1, yk minus 1. Okay, so where my k is 9 now. If my k is 9, then I'm going to have 14 combination 9. 14 combination 9. Your s will be what? 2x. That's your s. That is 2x. So n, that is 14 minus 9. In fact, that was 14 minus 8, because k minus 1, that is 8. So that will give you 6. In fact, that was how we knew it will give us that. Then your y, that is minus 1 over s, everything raised to power what? I think everything raised to power 8. Everything raised to power 8. Everything raised to power 8. So if you do it further, then you have 14 combination 9. Then you have what? 2s, everything raised by 6, 1 over s, everything raised by 8. The question initially asks us to find, let me know, is it the coefficient or the term? Okay, find the coefficient of s raised by 6. So, yeah. Then you are going to have, what is 14 combination 9? What will be your 14 combination 9? You find 14 combination 9, and something 2 raised by 6 will also come out from here. Then 2 raised by 6 multiplied by what you obtain here, their product will serve as the coefficient of this guy. So that is that. Yeah, I think, okay, 2002, thank you. I think the time is not on our side. Any other question before I call it a day? Any question before I call it a day? Or even if you don't want to stress yourself, another thing you can do, if this is 6, that's going to be, 8 as well. So that is that. K minus 1, this should be 8. It should be 8. It should be 8 because it is K minus 1. Another thing is, if you don't want to stress yourself, when I use Pascal Triangle, I said, as soon as one is increasing, the other will be decreasing. It means for me to have 6 here, which is 2s, everything is by 6, this guy will be 8. So 1 over s, everything is by 8. And then you have 14 combination 8. That is what you obtain here. Because that will also be, if you check the one I use for combination here, we started from 0, then it's also increasing. It's also increasing. That's how you are going to do that. Any other question, guys, before we call it a day? Any question? Which one? No, for this one, the coefficient will now be what? What you obtain here. This one will give me, what do you call it? 2 raised power what? That is 32. I hope you understand now. So that is 32. Yeah, 64, sorry, but you have to be careful. You see the reason why I said we have to be careful? Because this one is also having, at the end of the day, this one will be 1 over s raised by 8. And s raised by 6 divided by s raised by 8 will not give you s raised by 6 any longer. You understand now? So then what are you going to do? What do you think we are going to do to ensure we have 6 at the end of the day? I think what we are going to do to ensure we have s raised by 6 at the end of the day is that if you have s raised by 14, if you have s raised by 14 here, but this one cannot be s raised by 8, guys, what do you think we can do? So that you are going to have the same thing, but at the end of the day, you are going to get rid of this to be 6 altogether. But this plus this must be 14. Must be 6. For 6, 8, it is not possible. What of 12, 2? 12, 2 is not possible as well, because that will only be 10. So 13, 1 is not possible. What of 11, 3? 11, 3? 11, 3 is not possible. Then 9, 4. No. 11, 3, 10, 4. Yeah, it is 10, 4. I hope you understand what I'm doing, because if you add the power of this guy, it must be equal to be 14. And the reason why we cannot use directly here is that at the end of the day, this will give me 64 times s raised by 6, then multiplied by 1 over s raised by 8, which will later give me 64 s raised by minus 2. But we are only asked to find s raised by 6. It means for you to find that is to have what? 14 combination 4, 2s raised to power 10, 1 over s raised to power 4. You understand now? So then at the end of the day, I'm going to have whatever the value of 14 combination 4, this will now be give me 14 combination 4, 2 raised to power 10, s raised to power 10, divided by, you know, this is the same thing as divided by s raised to power 4. And this guy will cancel this and give you s raised to power 6. Then you have 14 combination 4, 10 raised to power 10, s raised to power 6. So then the product of this guy and this guy will be the coefficient of s raised to power 6. Find 14 combination 4. What you have as 14 combination 4, then you multiply it by 2 raised to power 10. That will be your coefficient. And if for this sense, at times they may just write the answer as this. Since 14 combination, this is the product of 14 combination 4 and 2 raised to power 10 will give you a big number. You understand now? So because even if you want to find 14 combination 4, you know you are going to have 14 factorial divided by 10 factorial, 4 factorial. You understand? Anybody with calculator, and this will give me 14 times 13 times 12 times 11 times 10 factorial. Or let me remove this 4 factorial. And I think 4 factorial is 12, right? It's 24. 4 factorial is 24. Then you have 12 here, 1. 12 here, 2. So 2 here, 1, 2 here, 7. Then you have 77. 77 times 13 will give you the product of this. So yeah, just multiply, use your calculator, and that will be the coefficient. I hope you know the int I obtained. But let's say for this one, for this example, you have, look at this question. Maybe I asked you to find the coefficient of what? I asked you to find the coefficient of s raised to power 6. No, we can't have s raised to power 6 since this is 5. I asked you to find the coefficient of s raised to power 4. You know, before you can have s raised to power 4, it means the first time will be 2s, everything raised to power 4. And the second time will be what? Will be 1. Then you also have 5 combination 1. I hope you understand now. So then this will now give you 5 combination 1 times 2 raised to power 4, s raised to power 4, y over 2. So that is that. That is that. Yeah. So that should be the answer. Thank you. A few ways. So when you multiply it with 10, 2 raised to power 10, right? Yeah. So that is this. That is that. What is other question? I think the one I'm not sure with yet is this question. So maybe I should check it once more. Or if you have, does anybody have idea or who has done it before? I don't think we must not stop there. We must not stop where I stopped. It has to continue. I'm referring to this question, find the value of k such that, so you know, had it been, it has no inverse, it will have been easier. We know that the determinant is going to be 0. So, but now, we are still asked to find the inverse of k. So then you still have another matrix. That is strange. So find the value of k. Let me copy it here again. Find the values of k such that a is equal to 1, 2, k3 as an inverse. So find the value of k such that it has an inverse. Anybody? I'm coming. Let me quickly see something. I want to, because I know we must not stop there. Value. I'm coming, please. I want to, because I know I must not stop there. I must not stop there. Okay. Want to do my role, just go ahead. 1, 2, 1, 2, 1, 0. Okay, okay. Okay. and 0 minus 3. For the matrix, yeah, I think I'm correct. So that is for the value of k not equal to 3 over 2. So the value of k not equal to 3 over 2. And then your inverse of k will now be what? If it is multiplicative inverse, I think that should be 2 divided by 3. I think I'm correct. I'm correct. But if you have access to the textbook, it was taken. So you can let me so you can let me know. You can let me know. Any other question, guys?
No, sir. I think we're good. I think we'll email you if we have more questions.
Guys, any other question? So in the absence of no question, I think we should call it a day. So then if you have any question, please feel free to contact me. Thank you, guys, and I wish you the best in your assessment. Thank you and see you later. Bye.
Okay, thank you. Bye.